Now in question number 16, they have given that fx is x square minus x divided by x square plus 2x, and we have to find out ddx of f inverse x, right? Now the domain of the function fx is x belongs to any real value except -2 and 0, okay? In this domain, the function fx is defined. Now to find out f inverse x, let us say f inverse x is nothing but y. So that implies what? X is nothing but f of y, right? Now f of y is what? Fx is x square minus x divided by x square plus 2x. Now if I take x common and cancel, because x is not equals to 0, so we are going to redefine the function fx as fx equals to x minus 1 divided by x plus 2. Therefore fy will give you y minus 1 by y plus 2. Is it clear? Now if I cross multiply, what we are going to get? So if I take xy on that side, and if I take y common, we are going to get 1 minus x. So your y is nothing but 2x plus 1 divided by 1 minus x. Is it clear or not? Therefore, your f inverse x is nothing but 2x plus 1 divided by 1 minus x. Is it clear? Now we have to find out ddx of f inverse x. That is, we have to find out ddx of 2x plus 1 divided by 1 minus x. Okay? So if I go for it, apply the quotient rule. So 1 minus x whole square, 1 minus x into 2 plus 2x plus 1. Is it clear? Why I have given plus? Because actually it is minus, but when you differentiate 1 minus x, it will give you minus 1, which will give you plus over here. So what we are going to get, if I open the bracket, we are going to get 3 by 1 minus x whole square. Is it clear? Therefore, our option B is correct for question number 16. Option B is correct for question number 16. Is it clear to all of you? In question number 17, they have given that fx is fractional part of x square minus fractional part of x whole square. We have to check whether the function is continuous or not at the point x equals to 2 and minus 2. Why I have chosen these 2 points? Because if you see the options, you will find that there are only 2 points they have given us. That is, one is 2 and another one is minus 2. So we have to check whether the function is continuous or not at the point x equals to 2 and minus 2, and accordingly we will decide the option. So let us first check whether the function is continuous or not at the point x equals to 2. So we are taking the left hand limit at the point x equals to 2. So what we are getting? Limit h approaches to 0, f of 2 minus h, where h is very, very small positive number. Limit h approaches to 0. So we are getting what? Is it clear? Now you see, if I open the bracket here, we are going to get 4 minus 4h plus h square minus 2 minus h whole square, right? Now you observe carefully that we have to find out its fractional part for this one. Now 4 minus 4h plus h square will give you a number which is little less than 4. Okay, it is 3 point something. Now to get the fractional part, all we will do is, we will subtract minus 3 from here. Is it clear? Because 4 minus 4h plus h square is basically a number which is little less than 4. So little less than 4 means it is 3 point something. So if I subtract 3 from that number, we are going to get that fractional part. From here also you see it is 2 minus h. 2 minus h is a very, very small positive number. So 2 minus h will give you 1 point something. So to get the fractional part, all we do is we subtract 1 from here. Is it clear? And square is there, so square is there. Okay, now what we are going to get from here? We are going to get here as 1 minus 4h plus h square, and this is basically 1 minus h. So if we open the bracket, a minus b whole square, what we are going to get? Is it clear? Now if as h is approaching towards 0, so we are going to get from here as 1 minus 1, so it's 0. Is it clear? Therefore, the left hand limit at the point x equals to 2 is 0. Now let us check the right hand limit at the point x equals to 2. We got left hand limit at x equals to 2 is 0. So for right hand limit, limit h approaches to 0, 2 plus h whole square minus 2 plus h whole square. So what we are getting? This is basically 4 plus 4h plus h square. This is 2 plus h whole square. Now look at carefully. Since h is a very, very small positive number, so this number will give you little more than 4. To get the fractional part, all we have to do is we have to subtract 4 from here. We have to subtract 4 from here to get the value, that is the fractional part from this term. Now from this one what we are getting? It's 2 plus h. 2 plus h means it is 2 point something. Okay, to get the fractional part, it will be 2 plus h minus 2 and whole square is there, the whole square is there. So now what we are going to get? From this part we are going to get 0, and from this part again we are going to get 0. So your answer is 0. Is it clear? Therefore, your right hand limit at the point x equals to 2 is again coming to 0. Moreover, what is f of 2? What is f of 2? This is nothing but 2 square minus fractional part of 2 whole square. Now 2 square means 4. The fractional part of 4 is 0. Again the fractional part of 2 is again 0. So ultimately it is coming to 0. Therefore what we got, that at x equals to 2, the left hand limit equals to the right hand limit equals to the value of the function. Therefore we will say that the function is continuous at x equals to 2. At x equals to 2, the function is continuous. Is it clear? Now we will check whether the function is continuous or not at the point x equals to minus 2. Let me rub it. Now, at x equals to minus 2, what we are going to get? The left hand limit. Limit h approaches to 0, f of minus 2 minus h. So we are getting limit h approaches to 0, fractional part of minus 2 minus h whole square. The fractional part minus 2 minus h whole square. So what we are going to get? If I expand it, we are going to get you see, in this case, we are getting minus 2 minus h. We all know that fractional part of minus x can always be written as 1 minus fractional part of x. Is it clear? So in this case we can write 1 minus fractional part of 2 plus h whole square. Have you understood this or not? Fractional part of minus x can be written as 1 minus fractional part of x. So fractional part of minus 2 plus h can be written as 1 minus fractional part of 2 plus h, and the whole square is there, the whole square is there. So what we are getting now? In this case, observe 4 plus some positive value. To get the fractional part, we have to subtract 4 from here. So this is the fractional part what we got from the first term. And from the second one, you observe carefully, it's 2 plus h, means it is 2 point something. To get the fractional part of this, all we will do is we will subtract 2 from there. Is it clear? We will subtract 2 from there to get the fractional part of whatever we will get from this term. So what we are getting ultimately? Limit h approaches to 0. It's 4h plus h square minus. If I open the brackets, it's 1 minus h whole square. So what we are getting? It's 0. It's minus 1. So it's coming to minus 1. Therefore, left hand limit at x equals to minus 2 is minus 1. Is it clear to all of you? Now let us go for the right hand limit. For the right hand limit, we are doing limit h approaches to 0, f of minus 2 plus h. So we are getting what? Limit h approaches to 0, fractional part of minus 2 plus h whole square minus fractional part of minus 2 plus h whole square. So what we are going to get from here? If I open the bracket, it is again minus 2 plus h. Minus 2 plus h means if I take minus common, it is 2 minus h. So it can be written as 1 minus fractional part of 2 minus h. Is it clear to all of you? Have you understood this? Because if I take a minus common, it is going to come 2 minus h. So as just now I told you, fractional part of minus x can be written as 1 minus fractional part of x. That's exactly what I have done there. In this case again, 4 minus some positive value. So it is 3 point something. To get the fractional part, we are subtracting 4 from here. 3 from here. Minus 2 minus h. Again, it is a number which is little less than 1. So to get the fractional part, we are subtracting 1 from here, right? So what we are getting ultimately? Is it clear to all of you? Okay, now if I put h equals to 0, so we are going to get 1 in the right hand side, right hand limit, okay? Therefore, the right hand limit at the point x equals to minus 2 is nothing but 1, okay? Therefore, the right hand limit is nothing but 1. Therefore, what you will say? That the function fx is not continuous at the point x equals to minus 2. It is continuous at x equals to 2, but it is not continuous at x equals to minus 2. Therefore, my option A is correct. Therefore, the option A is correct for question number 17. Option A is correct. Is it clear to all of you? In question number 18, they have asked us to find out the sum of n terms of this series. Okay, so let me just find out the nth term of this series, which will be nothing but 3, 5, 7, 9, and this goes on 2n terms divided by, it will be 1 square plus 2 square plus 3 square plus n square. So what we are going to get? Can you remember the formula for the sum of the squares of first n natural numbers? It's n into n plus 1 into 2n plus 1 divided by 6. So what we are going to get here? Is it clear? So now I'm writing Tn as Is it okay? Now in place of n, let us put 1, 2, 3 till n terms. So what we are going to get? T1 as T2 as, and this thing goes on, Tn as, is it clear? Now if I add the corresponding sides, if we add the corresponding sides, in the left hand side we are going to get the sum till n terms of this series Sn, and in the right hand side, observe carefully, these all terms will cancel. So we will be left with 1 minus 1 by n plus 1, which gives you 6n by n plus 1. Is it clear? So that is the sum till n terms of the given series in question number 18. Thus our option B is correct for question number 18. Is it clear to all of you? In question number 19, they have asked us to find out the summation for this expression. It is sigma n starts from 1 till 360, 1 divided by n under root n plus 1 plus n plus 1 into under root n. So, what I am doing here is, I am taking root n plus 1 common. So, we are left with root n plus root n plus 1. Is it clear? Now, if I rationalize this term, we are going to get and if we separate, we are going to get what? Is it clear to all of you? Absolutely. Okay. Now, in place of n, I am putting 1, 2, 3, 4 till 360. So, what we are going to get here? You observe carefully. When we put n is 1, we are getting 1 minus 1 by root 2. Now, when we put n equals to 2, we are going to get 1 by root 2 minus 1 by root 3. Is it clear? Now, if we add, every term will get cancelled except the first term and the last term. The last term will be under root 361. Is it clear? Absolutely. Okay. Now, what is 361? What is the square root of 361? It's 1 minus 1 by 19. So, we are getting what? 19 minus 1 by 19. Answer will be 18 by 19 for question number 19. And the option C is correct for question number 19. Is it clear to all of you? Option C is correct for question number 19. In question number 20, they have said that if 2x equals to y to the power 1 by 5 plus y to the power minus 1 by 5, and they have said that x square minus 1 d2y dx2 plus x dy dx equals to ky, then we have to find out what is the value of k. So let me start from the given condition, that is 2x equals to, let us say a plus 1 by a, where a is nothing but y to the power 1 by 5. Is it clear? Now, what we are going to get from here? A square minus 2xa plus 1 equals to 0. So that implies, if I solve it by Sridhar Acharya's method, we are going to get therefore, your y is coming to, a is nothing but y to the power 1 by 5. Therefore, y will be nothing but x plus minus under root x square minus 1 whole to the power 5. So let me just go for dy dx. So what we are going to get? Okay, now what we are going to get now? So here we are getting whole to the power 4, and in this case we are getting under root x square minus 1 plus minus x. Now let me take plus minus outside, so we are getting okay, so we are getting basically plus minus 5 under root x square minus 1. This thing will be x plus minus under root x square minus 1 whole to the power 5, isn't it? So what is this? This is nothing but your y. So we can write in this way, 5y by under root x square minus 1. Is it clear to all of you? Now let me just rub the upper portion. So we are getting dy dx as plus minus 5y by under root x square minus 1. Let me just cross multiply, which is equals to plus minus 5y. Now square both sides. Is it clear to all of you? Okay, now let me differentiate both sides with respect to x. Is it clear to all of you? Now, let me cancel 2 dy dx from both sides. So we are going to get 2 dy dx from both sides. Hello? Is it clear to all of you? So we got x square minus 1 d2y dx2 plus x dy dx equals to 25y. Now if we compare with the given condition, we can easily say that k is nothing but 25. Have you got it? So k is nothing but 25 for question number 20. B is correct. Hence our option B is correct for question number 20. Is it clear to all of you?